Thank you. Well, thank you for that nice introduction. I guess the original plan was that I was going to give an hour-and-a-half lecture on econometrics, but then we decided we'd just serve a little extra wine with dinner, would get the same effect. But that does lead me to my opening slide. I would like to give you a little quiz just to make sure you're awake. And the quiz is this: which day of the week are there the most searches for hangover? All right, so I want to try the audience here. Sunday. How many people say Sunday? Sunday. And how many people say Monday? And how many people say Tuesday? A pretty sedate group. Oh, there's one. Yeah. We always have one party animal in the room. So how do you find out? Well, what you do, of course, like any other question of this sort, you go to Google, and in this case, we go to something called Google Insights for Search, and you can enter in the query hangover. We said the United States. I'm looking at a particular period of time, and you can see this very, very regular pattern that peaks every Sunday. And people say, what is that big spike there? Well, that's January 1st. So you can see it's a very, very interesting query to look at. You can supplement it a little bit. You can scroll down and you can see the geographic distribution of searches on this term. And we can see New York is the hangover capital of the U.S., followed by Massachusetts, New Jersey, etc. And then here you can see the top searches and the rising searches for that term. Now, if you want, you can go a little further than just looking at a single term. Here are what the searches look like for hangover and vodka. And vodka searches peak every Saturday, with this being December 31st, and hangover searches peak the next day. Now, whether that's causality or correlation, I will leave that up to you to decide. All right, so that's a little example of Google Insights for Search. Here's another one. And that leads me to the topic, which is, can you use this for something socially useful, namely looking at predicting economic data? So the goal here is to take the economic index, unemployment, inflation, whatever, take the Google query data and then try to use that query data, that search data, to help you predict the value of this economic index. Now, it's a little much to ask for predictions in the far future, so what we're trying to do is look at contemporaneous correlations, and that's quite valuable because for most economic data, there's a reporting lag. So if you can find out halfway through the month, get an idea of what auto sales will look like or housing sales or anything else, that's still a big plus because the data is generally released with a lag of a week or so into the later months. So that's why I call it predicting the present. The goal isn't to look at the future, but to do what economists sometimes call nowcasting, of trying to get a picture of where the economy is now. So what we do in our modeling, and I'm going to go through this pretty quickly given the late hour, we fit the best model you can using just the economic time series itself. And that might, again, I'm going to give an example with unemployment in a few minutes. Then we add in this Google data as an additional predictor, usually a contemporaneous predictor because we're trying to look at that contemporaneous relationship. And then we look at how the one step ahead forecast works out, in our case using mean absolute error. You could use some other measure of fit if you want. And the important point is here, the turning points are particularly interesting since those are the hardest things to forecast. If you're looking at an economic series that's going up, 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 pretty easy. Down, 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 pretty easy. It's catching the turning points that's the hard part, and that's where you hope this data can help. Now, the data from Google is available on a daily or weekly basis, while the series of interest, most of the economic series, tend to be monthly data. It's not raw search engine counts, but it's what we call a normalized query share. So you look at the fraction of queries on hangover relative to the total number of queries, and then we normalize it so that it's 100 at the highest point in the series. There's a privacy filter. You have to have at least 50 or so distinct observations to show up in the data set because you're not trying to look at very idiosyncratic series. And it's sample data, so it changes a little bit from day to day. So let me give you an example. This is the unemployment data. Here I've plotted two government statistics. One is the initial claims to unemployment, that's in black. When you first become unemployed, you go down to the unemployment office, you file a claim to collect unemployment benefits, so that's the black line. And then the red line is the headline unemployment rate, which is what's reported in the newspaper every month. So the initial claims are reported every week. The data on unemployment rate is recorded every month. Those gray bars are recessions. Now, if you look at that data, you'll see that the initial claims for unemployment peak right at the end of every recession. So go right along those bars, and right at the end of the recession, you'll see the peak in the initial claims for unemployment. Now, before you get too impressed by that, I should tell you, economists get to define when a recession ends. And one of the things they look at is initial claims to unemployment. However, despite that tiny bit of circularity, it's still a very, very closely watched index for measuring what the performance of the economy is looking like at a given point in time. And then the unemployment rate tends to peak about 6 months, 8 months later than the initial claims to unemployment. So you should think about this as the initial claims are like water running into the sink, and then getting employed is like water running out of the sink, when the level of water in the sink is like the unemployment rate. And so when the initial claims dry up, when they stop increasing, then gradually the unemployment rate tends to decline. So that's the picture. And of course, it would be very handy to be able to predict those initial claims for unemployment a little bit in advance of the official releases. So here's one thing you could do. There's a tool called Google Correlate, which allows you to find the queries, the searches, that are the most correlated with some data. So what I did is I took the initial claims for unemployment from the Bureau of Labor Statistics, and I fed that in to this series. And what do you find? The query that's the most correlated with the actual initial claims to unemployment is, in fact, the query, sign up for unemployment. How do I sign up for unemployment? Where do I sign up for unemployment? How long does unemployment insurance last? All these different things. And if you look through the rest of the list, it's Idaho unemployment, Michigan unemployment, unemployment filing, etc. It's a kind of a nice example that with this series you find these queries that are, in fact, predictive of the contemporaneous value of the unemployment filings. And this is what the correlation looks like. In this case, the blue line is the actual initial claims for unemployment as reported by the Bureau of Labor Statistics, and the red line is the query volume on filing for unemployment. And you don't have to be much of a statistician to recognize those series seem to have a lot to do with each other. They're pretty closely correlated. So what you can do then is you can estimate a little model. And in this case, I deliberately chose the simplest possible model, which would be an autoregressive model of order 1. And you get an in-sample mean absolute error of about 3.25%. So just using a naive model that says the initial claims to unemployment this week will be whatever they were last week, plus a constant, that turns out to give you a pretty reasonable model. If you add in, on top of that, the filing for unemployment query, then your mean absolute error goes down a bit. And by the way, I want to emphasize, in these last cases, I'm just looking at the in-sample mean absolute error. Now, if I start looking at the actual forecast of trying to look at out-of-sample forecasting, estimate up to time t, forecast one period ahead, then what happens is the naive model gives you about a 3.3%. The mean absolute, add in this unemployment query, mean absolute error goes down a little bit. But the critical point is during the recession, the period when you're seeing this turning point, the change in the initial claims for unemployment, the mean absolute error without the Google data is about 4%. With the Google data, it's about 3.6%, so you're getting about a 9% improvement in the forecast error, the out-of-sample, one step ahead, rolling window forecast. So that's pretty handy because improving that forecasting by 9%, it's not fantastic leap, but it's definitely an improvement over what you'd be able to do without having access to that data. So, and here's a little picture of what the actual looks like, the naive forecasting model where you're just using the previous behavior, and then what happens when you add in that extra Google data. So that's example 1. Here's example 2. This is a little story about looking at destination planning. So a nice thing when you're planning your vacation to Hong Kong, in this case, be obvious thing to search on Google and say Hong Kong hotels, Hong Kong restaurants, things to do in Hong Kong, et cetera, Well, Hong Kong Tourist Board actually posts the visitors by country on their website, and you can download that data and compare it to what the Google search data looks like. And if you just plot the actual arrivals in black and the queries, travel-related queries on Hong Kong, looking at those series, you can see, gee, they have something to do with each other. These are US, Canada, Great Britain, Germany, and so on. So build a little model, and again, I'm using about the simplest time series model you can use, in this case, a seasonal autoregressive model, and I add in the queries as an additional predictor to that baseline model. That's giving a prediction about 6 weeks ahead of the actual data release, because I'm looking halfway through a particular month, say what does it look like for this month. That data ends up being released roughly with a 6-week lag, and here's what the forecasts look like. So you can see it's really giving you quite a reasonable forecast of these models. The worst case is Japan, but every other case seems to line up quite well. So destination planning, again, that's something that's very helpful if you're trying to figure out visitors to Disneyland or visitors to a ski resort or any of these other things. Knowing the queries that people are doing on that particular destination seem to be helpful in predicting the actual number of visitors. Okay, so those are 2 examples, and if you do a little searching, you can find several other examples that we've done in this area. Let me just raise a couple methodological and research challenges that comes up here. Is what do you do if you're trying to automate this process? Now, these 2 examples, it was very easy because we said, well, unemployment, we can look at this Google correlate, we find out filing for unemployment, that all seems very intuitive. We can look at Hong Kong, trips to Hong Kong, vacation planning to Hong Kong, that seems very intuitive. But there are cases where you don't really quite know what the appropriate predictors would be, and so you want a way to try to choose those in an automated manner as possible. So one of the difficulties that arises, or 3 of the difficulties that arise, are 1, this problem of common seasonality and trend. And everybody, I'm sure, has seen examples of time series that look very, very highly correlated, and it's really a spurious correlation. So for example, if you just try to estimate auto sales, one pretty good predictor of auto sales turns out to be queries on bathing suits or baseball, because auto sales peak in the summer, and so do queries on bathing suits and baseball. So having a common seasonality gives you a spurious correlation in these series. There's also this problem that I like to refer to as fat regression. Namely, we have millions of possible predictors of these series because we have millions of different queries that come into Google. And if you have more variables than things to predict, you can always predict perfectly by choosing appropriately. And finally, the last point is what you might call, what's called the problem of incremental predictability. you want to look not just at the raw prediction, but how well the prediction does as compared to a simple baseline model. So we want to figure out ways to address each of these challenges. Here's a little example just to give you a flavor of this. Obviously, I don't have time to go into it in great detail. In the chart on the top, I have U.S. retail sales, just the raw data, total number of retail sales, total value of retail sales in the U.S. over this from 2004. In the bottom line, I have the seasonally adjusted series of the same thing that's up in the top line. There's a very heavy seasonal pattern because retail sales obviously peak every Christmas time. That's that big spike every Christmas. They fall down dramatically in January. And if you kind of look at that top line, you can see this drop back in 2008, 2009. Once you pull out that seasonal pattern, that drop, which was the recession, becomes very, very apparent. So depending on whether you're looking at the unadjusted data, the raw data, or the seasonal data, you get a rather different view of what's going on in this series. Now, maybe your goal is to try to predict the raw sales, in which case you probably want to use the unadjusted data. Or maybe your goal is try to predict this underlying trend, in which case you want to focus on the adjusted data. Well, we have some methods for variable selection. And if you try to find the categories of Google queries that are the best predictor of retail sales non-seasonally adjusted, the raw data, turns out the best predictor is queries on apparel. Because, you're always getting a sweater at Christmas time or a scarf or something like this. So it's those queries that end up being very highly correlated with that seasonally unadjusted data. But if you look down at the seasonally adjusted data, which is helping to identify that recession, well, then you see the best predictor is coupons and rebates. And we saw that back in 2009 when the economy headed south, queries on coupons and rebates headed north because people were getting a lot more price sensitive and were looking for ways to save money. Bankruptcy, pretty not too surprising. Welfare and unemployment, not surprising. Social services and so on. All of these categories of queries help in predicting the onset of that recession. So if we look at the retail sales and the apparel, what's common to those two series is that Christmas spike. So when you say what data from Google is helping you to predict retail sales, it's going to say, well, things that are very highly seasonal, because that's the most obvious characteristic of that time series. But if we look at the seasonally adjusted data, up on top, that's the retail sales adjusted, taking out that seasonality. The most notable effect is the recession, and down here you can see that upturn in the queries on coupons and sales that occur at roughly the same time. So that's giving you a much better picture of what's going on with the underlying economic trend. Suppose you go back to Google Correlate. I showed you earlier works so well for that initial claims to unemployment. If you load in retail sales and say find the queries that are most correlated with retail sales, you get a whole bunch of malls. The Oaks, Coral Square, Suburban Square, Pines Mall, Burbank Mall. Basically, the queries on malls are good predictors of the queries of the actual retail sales because they have the same seasonality. It's exactly the story with the bathing suits and auto sales or baseball and auto sales. It's really picking up the pattern that you already know about, not the pattern that you're most interested in is when those retail sales are falling short of what you would otherwise predict. So I'll give you one last example, and then we'll talk a little bit about some of this work. This is consumer sentiment. The University of Michigan's been running consumer sentiment surveys for, I think, about 40 years, where they call people up and they ask them questions about how they feel about the economy, and then they report an index of consumer sentiment using the responses to this survey. So this is a picture of what it looks like. That big drop is, of course, the recession. We saw a big drop, some return. went back down again, kind of went along for a ways, and right at the end of that series we saw a large drop in consumer sentiment, which turns out to have been most likely due to the budget negotiations that went on about 10 months ago, where there wasn't so much a economic disappointment as a disappointment with the political process that made people so pessimistic at that time. So what we tried to do is we tried to find the Google verticals, the Google categories of queries that are the most predictive of consumer sentiment. In this case, we had about 90-some observations on consumer sentiment and 157 different Google verticals that we thought could potentially be predictive of that consumer sentiment. Now, kids, don't try this at home. This is a relatively dangerous thing to do when you're trying to do prediction with more predictors than observations. But we have some methods that we think help alleviate this problem. And what we found was our predictors that were the most helpful in determining consumer sentiment were queries on retirement and pension. That was a positive predictor. And then negative predictor was business news. Quentin, you should pay attention to this. Yes. Hybrid and alternative vehicles, a negative predictor of consumer sentiment. That's actually a pretty easy one because those are very highly correlated with the price of gasoline, and the price of gasoline is known to be very highly correlated with consumer sentiment. Economics, it really is the dismal subject. When queries on economics go up, watch out because the economy is going down. Product reviews, well, that's a positive indicator. People like to buy things when they're feeling good. And then currencies and foreign exchange, that's a negative indicator. So you take these predictors, which again have come out of this pretty simple statistical model, and it gives you a pretty reasonable prediction of the consumer sentiment, about a 8% improvement over the naive model of just forecasting consumer sentiment this month as a function of consumer sentiment last month. So it does seem to have some predictive power. Now, I've described to you what you can do with some of that Google data, but there's lots of other data like that. If you look at MasterCard, they provide what they call spending pulse data, which will show you the amount of money that's charged on MasterCards by region, by day. So you know how much people are spending on a day-to-day basis. UPS and FedEx provide data on product shipment. That's an economic indicator. Walmart, Target provide numbers on same-store sales. That's also an economic indicator. Supermarket scanner data is now widely available. And of course, search engine data, what I've just been talking about. So there's a huge amount of private sector data which is measuring economic activity for that sector. The government, on the other hand, has long historical series. They really try to keep historical integrity to those series, but they're very labor intensive and they're typically very low frequency. The private sector data, Walmart can tell you how much they sold at a given store yesterday, so it's very high frequency data. Government data tends to be very low frequency. And so the challenge that I think we face in the next decade is figuring out how to combine that high frequency private sector data with the low frequency government data in a way that helps you improve your predictions and analysis of economic activity. So let me leave you with that thought and invite Michael to come up and we'll talk a little bit about some of these issues. And of course, you'll have a chance to ask questions as well. Thank you.
So while Hal's getting mic'd up, we're going to talk mostly about the comparison of different orders of autocorrelative.
Thank you.
Actually, I want to spend just enough time to maybe provoke Hal a little bit, such that you'll have some questions to ask. I won't keep you too long because I know it's the end of the evening and we're starting early tomorrow. 8:30 sharp, I believe what I said. And then I want to wrap up with something I like to do called the lightning round. So we'll try to get Hal to come up with some quick answers to some provocative questions.
I feel like I'm on Jon Stewart here. All right.
We could try that.
Okay.
At least it's not Stephen Colbert. So, super interesting stuff. How is this useful to people who aren't economists? How do you make money with this? For instance?
It's a good question, because the reason we made Search Insights available, and I want to emphasize, all the data I used was publicly available data. You can go to Search Insights, you can download that data, click on the CSV file, and all the work I've done in this area, I've really restricted myself to using only data that's available to everyone. So it is a situation where, yes, kids, you can try this at home. Just be dangerous and be sure that mom and dad know what you're doing. So the original motivation was, in fact, for advertisers, because they could look at how queries responded on their own brand, for example. So when Chevrolet introduces the Chevy Volt, they can put an ad campaign here, an ad campaign there, and then they could look at the query responses, the searches that people are doing on Chevrolet Volt. It gives them an idea of how that brand recognition works. So you can do that if you're an advertiser. You can do that if you're any kind of company, because it's a much, much more rapid and a much more inexpensive way to do market research of whether people are recognizing your particular query.
So market research is one application. What else? What else could be?
We saw another one that was kind of nice. The Council of Economic Advisors asked us to look at the impact of the Cash for Clunkers program. So, of course, if you know that the automobile sales are going to be discounted next month, you're going to refrain from buying this month. And when did people first become aware of the program, and when would you expect there would be some impact on sales? And so just looking for terms like Cash for Clunkers helps you tell that. And there are other things of the same sort. If you're looking at mortgage defaults, well, there are queries. How do I default on my mortgage? How do I walk away from my mortgage? You can look at this on both an aggregate and a local point of view. So there's lots of different applications that you can do in this area.
So on the mortgage thing, it seems like, wouldn't this be useful for trading? Wouldn't Google be a pretty good hedge fund? You have a lot of cash.
Yeah. Well, one of the great things about the financial sector is they'll try anything. So
it's a great thing.
Yeah. So it's a great thing, because they really are looking for that edge, and I can tell you for sure that there are hedge funds and investment companies that are looking at this kind of data. Now, it's not what people think right away. It's not very helpful predicting prices, because prices change on a second-by-second basis, and this is essentially daily data. The government statistics come out on a monthly level, so having daily or weekly data is helpful in predicting that. But if you look at things like you're an analyst who's trying to forecast United Airlines traffic, you can look for queries on United Airlines or airline travel or these destinations or that destinations. It gives you an idea of whether activity is going up or down. And so that's the main use that the investment banker or the analysts are using for this kind of data.
Can I look up what investment bankers are searching for?
No. I can, but you can't. No. I can't either, but anyway.
You mentioned some other sources of data. For instance,
Sure.
So you had a bunch of logos up there. How could you use data from those other sources? Do interesting things?
So there's a lot of interesting things going on in Silicon Valley now. Intuit is releasing a small business employment index on a monthly basis, because Intuit has QuickBooks. That gives you insight into small and medium-sized enterprise employment, which is very, very hard to get by any other means. Zillow is releasing real estate sales data on a monthly basis. LinkedIn has been releasing rapidly growing job categories. What else? Monster's got a Help Wanted index that they're releasing, because many of these companies are doing this data collection and aggregation. They've got it on a real-time basis internally, And it's very, very little extra work to make this available externally. So I think these kinds of data series, as we accumulate more of them, and over a longer period of time, are going to be very helpful in looking at economic activity in the future.
How's Google using this data?
Well, we look at it sometimes in terms of getting for example, this business on the coupons and rebates and shopping. That shows up across countries as times get bad. People become much more price sensitive, and you can see this happening in countries in Europe even now. Oh. So there are cases. It's something where there are also the Bank of Italy, the Bank of England, the European Central Bank, the Federal Reserve Bank in New York, and a few others I've forgotten have also been using this data to look at unemployment-related issues. So you can find several research papers on this topic.
How many people in Greece and Spain are saying, how do I get my money out?
Yes. Well, I've asked exactly this question, and if I could find somebody who spoke Greek, I'd be able to answer it.
Google Translate, I think, works.
Yeah.
What are some of the risks of predicting the present this way? Are there things that could go wrong doing this type of stuff?
Well, there is this issue that the system can be spammed to some degree. So if you tried to issue a lot of fake queries. Now, obviously, we have spam filters that we use for detecting this kind of thing, but it's a cat and mouse game. There's also the case that it's a particular segment of the population. So if you look in the U.S., 85% of the population has internet access. These are the most affluent members in general, so it's the people that are driving the economic activity. If you go to a country where there's only a 10% penetration of the internet, then you worry about whether you have really a representative sample. So it's not a complete solution by any means, but it's an extra variable that you can use in signaling economic activity.
Can you say more about that? Because the received impression is that you look at all Google searches, that must be everybody,
yeah.
Right?
Well, it's interesting because one of the research papers I looked at recently was done at the Bank of Chile, and they said they had about a 35% internet access usage in Chile. But it tended to be the people who had the most money and were spending the most, and so for consumer-related queries, that was a relevant sector. But you could also find places where penetration is much lower and you're getting noisier data. So even looking at this query, the hangover query that I showed earlier, that shows up pretty strongly in countries where there's relatively high internet penetration. So it seems to be a pretty real phenomenon.
And high drinking
yes.
penetration, I presume. So what does it take for a company or an organization, people to do this at home? What do you actually have to do?
So the issue is you've got the data. You can go to the Google Search Insights page. You can explore different queries. You can click on the CSV file, download it. You can look at your own data. What's needed is really just the expertise to be able to do this time series methods, and they aren't terribly sophisticated. Again, I've deliberately restricted myself to doing pretty simple methods here because the point is to show that this is helpful in doing predictions even if you're using relatively naive forecasts. So basically the missing ingredient is the expertise.
So there was some discussion about expertise
Yep.
earlier this afternoon, and you've famously said, for the next 10 years, I believe it was the sexy job would be statistician.
That's right. Statisticians love me for this.
Hot. So say more. How's that going? You said that actually a while ago in the New York Times, as I recall.
That's right. It's true. I think the basic logic is you want to find something that's ubiquitous and cheap, and then if you have something that's scarce and expensive, which is highly correlated with that ubiquitous and cheap, or is highly complementary to that, then you're in a really good position. It's like you have a monopoly on left shoes and right shoes are widely available. So putting the two together is what gives you the value. and that puts you in a good position. Well, now I would say the data is ubiquitous and cheap, and the expertise to manage that data is what's scarce and expensive. So if you talk to computer science departments, statistics departments, they will definitely tell you the enrollments have gone way up, the applicants have gone way up, and it's pretty much a good place to be.
How about schools of information?
I think they're doing well now, because we've seen the same thing happen there. And I want to emphasize, there is the technical component, which I think is quite important, knowing the statistics and knowing the computer science, but there's also visualization is really important, being able to communicate, dealing with the database, data access and manipulation, that's important. So there's a number of skills that go into making this work.
Why don't we open it up to the audience? See if there are questions. Yes?
Yeah, Hal, have you tried political forecasting? When you talk about
Yes.
forecasting.
Yeah, so it's.
If you can't hear,
I'll repeat. Yeah, I'll repeat the question. The question is, have I tried political forecasting? And what happens is, if you look at, let's say, debates, or you look at candidates, what happens is the new candidate, the one who's not as well known, is going to get the query volume. Now, we don't have a good way to tell whether that's positive or negative, because we don't have any affect analysis. But we did look, for example, at Clegg, the British Liberal candidate. He by far got the most queries because he was the one who had the least public visibility. Scott Brown in Massachusetts, same thing. So when you look at the candidates, typically it will be the person who's least known is getting the most query volume. So it's not necessarily predictive of election outcomes, it's just predictive of interest.
Yes?
I just wanted to chime in that ever since Hal said statisticians were sexy or wanted to be, our undergraduate major has tripled. 3 years it's tripled.
There's a natural limit. Yes?
So I think this is really interesting work. I wanted to ask about the Google Flu Trends project,
Yep.
which is related.
Yep.
So in the initial paper, the predictive model worked very well, and then the swine flu happened, and
Right.
your colleagues published a very interesting paper showing how the model basically broke down during the swine flu. And so I'm wondering to what extent that example suggests other kinds of scope conditions for this kind of work.
Right. So, yeah, that's a very good point. It was about the Google Flu Trends. People don't quite understand the goal of flu trends. It's not actually predict the flu this year, because the flu this year tends to be pretty darn predictable just using a seasonal model, because the flu has a common seasonal pattern. So good predictor of the flu incidence this week is what it was 52 weeks ago. But what it's trying to do is it's trying to detect deviations from that seasonal pattern, which means early warning signs on epidemics. When the flu virus mutates and you're seeing a much bigger spike in flu this week than you would have anticipated by looking at the historical relationship. Now, fortunately or unfortunately, we've only had one example of that, and that was the swine flu that you mentioned. It showed up first in Mexico, which has a relatively low internet penetration, and we didn't have a Spanish language version of Flu Trends, so we kind of missed that one completely. But now they've got a pretty good model. It's extended around the world. They've emphasized looking at places where flu outbreaks are likely, and maybe the next time there's a departure from the seasonal pattern, they'll be able to detect it. At least that's the hope.
Anything else? Yes?
You had an interesting chart earlier where you looked at the initial filings for unemployment
Right.
and then the survey-based data. And anecdotally, my understanding is that the survey-based data is based on something like 60,000 people across the entire United States, which is, if you drill down to a metro area, that's a very small sample, right?
Right.
Hundreds of people. So can you speak a little bit, not just about the predictive power of leveraging private sector data, but using it to get a more granular microscope on what's happening within the country?
Yeah, that's a really excellent question, because one of the things that you could do with this is you could fit, say, a model at the national level using national data and then extrapolate down to the state or even metro level. So you take this consumer confidence index that's published at a national level, you can take the same predictors that I just showed you and predict what California consumer confidence looks like, or New York consumer confidence, or Texas. It does break down when you get to the smaller states. You get much more noise. But if you look at the big states, it appears to be quite helpful in giving you that regional level confidence. Metro level, it's a little iffy. But definitely at large states, you could do that kind of extrapolation.
Anything else before the lightning round? Lightning round it is.
All right.
Ready, Hal?
All right.
Quick set of questions, quick set of answers. Number one, what's the most valuable application of predicting the present?
Economic time series.
Spoken by a professional economist.
Right.
What is the scariest application of predicting the present?
Good question. Scariest application of predicting the present. Well, it's easy to misuse it because spurious correlations are all over the place. If you don't know what you're doing, it's very easy to get caught in that common seasonality trap. There are a lot of little things you have to watch out for.
All right. What is data that people don't normally think of that's surprisingly valuable?
Surprisingly valuable. Well, supermarket scanner data is all over the place, and economists have been doing lots of interesting things with it. You know, you've got people out there collecting inflation measures by writing numbers down in a notebook. It's much easier just to go to that supermarket scanner data and look at the numbers there. So that's a ubiquitous source of data, but it really gives you lots of insights into consumer behavior.
Makes sense. What data do you personally want to keep private?
Oh my gosh, how could I tell you? That's a trick question, John.
It doesn't have to be the values, it can just be the field.
Just be the field. Well, I think I'm going to have to pass on that one.
That's like meta-private. Okay. What industry has the most to gain from predicting the present?
I think there's a lot of issues in marketing, advertising, that kind of stuff, brand recognition. Are people getting the message? Are they hearing what I'm saying in terms of promoting a particular brand or particular concept? So just take a very simple example, movies. So people are showing movie previews on TV. If you're interested in the movie, you go query it. You go to the site, see what it is. Those queries are very helpful in predicting the interest level that the ads may have generated. So that kind of thing, I think, is going to be quite common.
What industry is most threatened by predicting the present?
Well, I think if you look at polling industries in general, response rates on polls are going down, down, down. And they're finding it hard to get responses. So to the extent that this can replace these more costly ways of gathering information about consumer intent, they're somewhat threatened.
Market research, bad.
Yep.
Okay. From what country will the next big innovation around data come?
Ooh, that is a tough one. I've got to say the U.S. is the most likely candidate. It's the biggest candidate. There's lots going on. We've got a lot of interest in this subject, so I'm kind of guessing it'll come out of the U.S.
USA.
Yes.
Okay. Other than yourself, who is the smartest person thinking about this?
Well, I am pleased to see that there are people, the two groups that are the most interested are people on Wall Street for the reasons I mentioned. They're always looking for an edge, and people at central banks because it's their job to try to understand the state of the economy and take appropriate action. So they're very interested in this set of issues as well.
Hiring opportunity, right?
Yep.
All right. If you weren't working for Google, what company would you work for?
Boy, that's tough. What can I say? UC Berkeley, or is that?
Homer. Speaking of UC Berkeley, as the final wrap-up question, as the founding dean of the iSchool, what word comes to your mind when you think about the school?
what word? Possibilities. Possibilities. Lots of possibilities. Okay, thank you.
Thank you all.